Welcome to qnawire.
Let us try W6 cross 9 section, and by property and by the table given in the textbook, we assume that the length of the column L is equals to 14 feet and the axial load it can withstand is 40 kip. Now let us obtain the property of W6 cross 9 wide plan section from the wide plan section table Appendix B in the textbook. We have cross sectional area of the section is equals to 2.68 inches square and the radius of gyration about y axis is equals to 0.905 inches. Now let's calculate the cylinderness ratio. So cylinderness ratio will be KL divided by R about y axis. This will be equals to the value of K is 0.5 since both end is pinned, since both end is fixed, multiplied by the length is given as 14 feet, so it is 14 multiplied by 12 inches divided by the radius of gyration, that is 0.905. So it will give us a value of 92.82. So this is the cylinderness ratio. Now let's calculate cylinderness ratio using equation 13.22. So using equation 13.22 we have cylinderness ratio. This is equals to square root of 2 pi square E divided by sigma y. Let's put the values here. It will be 2 pi square. The value of E is 29 multiplied by 10 to the power of 3 and the value of sigma y is 50. So it will give us a value of 107. Now since the value of cylinderness ratio by using equation 13.22 is greater than the cylinderness ratio we have found, so column is an intermediate column, hence column is intermediate column. It is not long column. Let us use equation 1323 to calculate allowable stress to find sigma allowable. So sigma allowable will be equals to, this will be equals to 1 minus cylinderness ratio square S square divided by cylinderness ratio square for the column using the formula given in section 13.22 multiplied with sigma y divided by 5 divided by 3 plus 3 multiplied with cylinderness ratio S divided by 8 multiplied with cylinderness ratio calculated by equation 13.22 minus cylinderness ratio cube divided by 8 multiplied with cylinderness ratio calculated with the section 13.22 cube. So let us put the values. So from here we get sigma allowable is equals to 1 minus 92.82 square divided by 107 square multiplied with 2 whole divided by this multiplied with 50 whole divided by 5 divided by 3 plus 3 multiplied with 92.82 divided by 8 multiplied with 107 minus 92.82 cube divided by 8 multiplied with 107 cube. So after solving we get allowable stress is equals to 16.33 KSI. ASI. Now let us calculate the allowable load on the column. So allowable load on the column will be equals to allowable stress on the column multiplied with the area. So let us substitute the value 16.33 multiplied with 2.68. So it will give us a value of allowable load is equals to 43.8 kip. Now, since the allowable load obtained is greater than the axial load, so the column can withstand the load. So we can use W 6 cross 9 section. It is because the allowable load we obtained is greater than the axial load.